Alright guys, what's going on? Welcome to another Android tutorial. Today I'm going to handle the draw pass of a standard view. Now, just so you know, let me just scale this, turn this on. Get my emulator going, forgot to start it up. Only takes a second anyway because of a hardware accelerated execution manager. Thank you Intel. Anyway, today we're going to do the draw pass. And the very first thing I'm going to tell you is the golden rule of drawing in Android. Never, ever, 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 ever allocate memory inside the draw pass or inside the draw method. Just don't. Because allocation of memory will trigger garbage collection at some point. Because the more memory you allocate, it has to clean more memory to do that. Allocated memory causes a stutter or causes a slight pause of the system as the garbage collector runs. Now it's been improved immensely over years, but it'll still happen. But if you're doing it in the draw pass, let's say you've got a 6-second animation running at maximum speed, we'll say 70 frames a second, or we'll say 60 frames a second as standard. 660 is 360 frames, that's 360 memory allocations. You're going to cause a garbage collection. If you're doing lots of just don't allocate memory in the draw pass. So anyway, we're back with our color view, which was going to display a single color, any color we want, and it's minimum at 10 dips high. So we've already handled measuring. The next method we're going to do is we have our measure pass ready, so we're going to handle what's called the onDraw call. And this is the call that will handle all of our drawing in here. Now you'll see here the super.onDraw. We're going to leave that be because the super onDraw is needed for backgrounds. So sometimes the canvas the view might draw extra stuff. So handling stuff like background color, background drawables, all that kind of stuff, that's all handled for you. The view handles that nicely. So we want to do our custom drawing on top of whatever the view has already done. Sorry about that. So what we want to do is we want to fill our canvas with the right color. So the measure pass has already determined what size our canvas should be. So what we're going to do in here is we're simply going to tell the canvas to draw a color. Now remember how we can't allocate memory in the draw pass, so we're going to allocate our memory in our init function, which is called from our constructors. So we're going to have color, or we're going to have int color, and we're just going to say, I know I could do this in one line, but I'm just doing it here for demonstration. Color.blue, so that's just pure blue. And essentially all we're going to do is I'm going to draw a color on the canvas. Now, I just end my paper videos, if you've seen those. The canvas drawing system is made up of 3 parts: the bitmap, the canvas, and the paint. The bitmap is the view's sort of area that it has on screen, which we already have. The system has allocated the area, the frame, and it's all ready to go. The canvas here, as you can see, canvas has the canvas has set up what we need it to do. So the canvas is already pointing at that bitmap. So when we draw onto the canvas, it will draw onto that bitmap, which the system will then give to the graphics card, and it will draw that on screen. And then we have the paint. The paint defines how we draw something to the bitmap or to the canvas. So what we need to do is we need to define a paint with the color blue. So what we're going to do is we're going to make a private variable, and it's just paint. And we're going to say paint equals new paint. And in here we can put some flags in now. So there's some nice flags with the paint. There's anti-aliasing, which you need. You're going to have the paint anti-alias flag. Okay. We can add more flags at a later date, but we have underline, subpixel, text, strike-through text, so to put strike-throughs for drawing text, dithering, filter bitmaps, which allows us to keep bitmaps to be nice and smooth, and to do proper like filtering on them and not just throw them on there and make them blurry, or not cause problems with pixelation. So we've created a paint. So I'm going to set our color, and we're going to set that to our color. So now we have our paint prepared. Everything's allocated at creation time, so the init's only ever called once. This is a great place to initialize paints, canvases, bitmaps, and blah 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 blah. Anyway, let's do our draw. So we have canvas dot draw color, or yeah, draw color. Now the canvas draw color actually has a method already set up for color, and we can just pass our color straight in, so we don't actually need the paint. And we'll show you what this does now in a second. Okay, so we'll just allow this to run. Might get a bit stuttery the video because Gradle will absolutely destroy your CPU as soon as it gets here. Come on. Come on, Gradle. I know you can't see me, but I'm giving Gradle the funny eye now. There we go. And enter. Whoops, I'm in my studio. Oh, I am an idiot. We never put our custom view in our layout. So to do a custom view in a layout, you very simply just do that. Now, as you can see, actually, we've put our custom view in. Because we've built the project, our view will actually correctly show up in the preview, which is very, very cool. Now, if we hadn't built the project, if you make changes and you don't build the project or run it, so you click build up here, make project, or this little button here, that will automatically build your project and handle, it'll just do the building and generate the classes needed, and then the studio can take those classes and use them to generate this. But anyway, just run the app so you can see how the color works. Just taking a drink. It's very warm here in Ireland. I'm absolutely roasting. Oh wow, I made like fucking error 101. My ID, my thing here, color view. There we go. I was trying to cast my color view into a text view. Android doesn't like that. And as you can see, we've got our nice blue strip. So that's the most basic form of drawing. Obviously, you know, if you want to do this, you just do a view in a background or a drawable or something. That's not interesting. The fun part comes now. Let's split it red and blue evenly. This is where it gets more complicated. So we're going to create two paints. We're going to need to use paint, so we're going to need to take two paints, one for red, one for blue. So, and then we're going to draw each one. So we're going to split the view horizontally in half and draw red on the right and blue on the left. So the first thing we need to do is we need to figure out how to draw partials of a view. And that's what we're going to do now is we're going to actually do it fully blue first, and then we'll move the red in. So the method we need here is draw rect. Okay? And the rect method takes two parameters. It takes a rect and a paint. So the rect defines what area of the view you need to draw. So the rect has four corners, the top, the left, the right, and the bottom, and they're kind of like the edges. And then by taking those, so what we want to do is we want to tell it to be blue on the left hand side. So we want to have our rect start at 0, 0 on the top left, and to go halfway across the view. So we need to do a bit of maths here to figure out what's going on. So what we're going to do is we need to first of all predefine our rect. So we're going to say private rect
semicolon.
What did I just hit?
Narrator settings with
Bugger.
exiting narrator.
Okay, somehow I managed to shortcut my way into the narrator. I don't even know what I was doing. But anyway, we're going to create a rect that we want. So we've established our rect. I'm actually going to call this out, just shift F for blue rect. I love IntelliJ's refactoring system. So now I've got our blue rect. Now we need to figure out how big our canvas is. There's a couple of ways of doing this. The easiest way to do the drawing like this is to use canvas dot get clip bounds. Now the reason we want to use canvas get clip bounds here and do a little bit of maths in the draw, generally if you're doing heavy maths you want to do it on the size changed as much as possible. But the reason we're doing it here is because the clip bounds also defines the padding. So if you put padding on the view, it'll be correct. So if you do it in the on-size change callback, sometimes you can get things a bit muddled up. But anyway, you call get clip bounds and you pass in a rect. Okay? Now as you can see, that's what I'm doing here. The reason you never use the other method, you never say blue rect equals get clip bounds, because the clip bounds method will allocate a rect inside itself, doing an draw time allocation, and then write that to the other rect. This writes it directly onto this rect, so that's written in there now. It's almost like a pointer. So now we've got all that set up. So now the next step is to split the rect in half. So we know that the rect will be the area. So what we're going to do is we want to get its width, chop it in half, or move the right hand side in. So we're going to say very simply canvas, or no, I'm saying blue rect. And we're going to need another int width. We're going to assign our width. So we've got our width of our rect. And now we want to do is we want to move the right hand side in half that distance. So we want to say blue rect dot right equals width over 2. Is that correct? That's assuming 0, 0. But let's say it starts at 10. That won't work because that's assuming 0, 0. No, we need to do this. We need to take away the width first. So we need to divide by that and then take it away. So what that'll do is, let's say our view is from 100 to 200. What this will do is it'll figure out the width, 50, because 100 to 250 pixels, and then it'll take away half that width from the right hand side, pushing it in. If we just said width over 2, it would move the right hand side to be 50, put it on the wrong side, and freck up our drawing. So then what we do is we just have our draw rect. So we say blue rect and paint. And now if we run this, we will see that this rect, it should be split in half, that view. Half of it will be blue. And as you can see, it's a perfect split. So that's pretty much that. We can do similar stuff, but what we're going to do now is we're going to do the same thing again. But this time we're going to move things a little bit differently. We're going to reuse some of our components. So we're going to rename this back to Rect because it makes sense. And now we've drawn one paint. So now we can modify our paint in the draw. And we say color.red. So now we can set our paint color to be a different color and then reuse the paint. So what we're going to do now is we're going to move our rect to the right hand side. So we need to reassign it back to 0. We already have our width. So what we're going to do now is we're going to add the left hand side, half the width onto the left hand side. If we add it on, it'll push it over to the right. So we're going to say rect.left equals rect.left plus, okay, you know what I'll do? I'll modify this a bit. Half width. Basically, you want to find the easiest way to do the minimum amount of work in the draw, because doing too much work in here will cause animation problems, and you don't want that. So if we add that, and then we say canvas dot draw rect, and we use our rect a second time in our paint, we should see the red and blue split nicely. And voila, perfect red and blue split. Now you're probably wondering why I didn't just fill it with one color, then fill it with another color. Because the drawing itself, the actual act of drawing those pixels in, is actually quite expensive. And you should always be aiming to draw the minimum you can without too much work. Because if you're doing a lot of maths to figure stuff out, it's not good either. So it's sort of a trade-off. So that's it for this video, guys. That's the very basics. I'm going to do a few more drawing videos because you can do some really, really neat stuff with drawing. Things like, corner. We're going to do pictures with corners. So anyway, guys, I suppose as always, been good talk, and I'll see you out there.